Welcome to integrating inverse trigonometric functions. So to do this, we're going to look at the rules that are on the reference sheet and just demonstrate how to use those. So the first one integrates to sine minus 1, and the second one integrates to 1 over a tan minus 1. The reason cos isn't on your integral sheet, if you have a minus on the top of the f dash, that can become minus sine minus 1. Or if you remember from the differentiation, that can become cos minus 1. But we'll just leave it as sine minus 1 because we get the same solutions. So here's three examples we're going to look at. You've just got to pick the reference. They're hopefully easy enough that if they've got a square root, they're sine or cos, and if they don't, then they're tan. So for the first one, 1 over 49 plus x squared. So note that the a is, so it's in the form of a squared, so 49 is 7 squared. The f of x is 1, so it's 1 or just x squared, and the differential of that is 1. So it's just the x part that we're focusing on, and the differential of that is just 1. So therefore we have the differential on top because that's the 1. So we're going to rewrite it in the form of 1 over a tan minus 1 of fx over a, where the a is 7 and the x is the f of x. So writing it, you get 1 over 7 tan minus 1 of x over 7 plus c. So you just got to be careful what the f of x is. Second one. So now let's have a look at it. We've got integral from 0 to 4, so we're obviously going to need to do substitution. But let's have a look at what it turns into. So we can tell again that it's a tan minus 1. So the a being squared, so that's 4 squared gets us 16. And what's the function? So what squared gets us 9x squared? Well, that's 3x. And so we need the derivative of the 3x on the top. So obviously we need a 3 on the top. So notice that that's how it all fits in. So in our second line, the integral from 0 to 4 of 1 over 4 squared plus 3x all squared. Need the derivative of 3 on the top, so I put a third out the front. So that gets me a third times 1 over a, or 1 over 4, tan minus 1 of 3x over 4. Replace the x with a 4 minus replacing the x with a 0, and we get 1/12 tan minus 1 of 3 minus tan minus 1 of 0. Tan minus 1 of 0 is 0, so I get a 12th tan minus 1 of 3. That's an exact answer, obviously. The third one is 1 over the square root. So we know this becomes sine minus 1. So once again, writing 49 as in the form of a squared, so that's 7 squared, and 16x squared in the form of some function squared. So 16x squared is 4x all squared. Note I need the f dash of x on the top, so I need 4 on the top. And once I have that, I can then move straight into the sine minus 1 rule. So if I need a 4 on the top, I need to put a quarter out the front. So I get a quarter, 4 over 7 squared, the square root of 7 squared minus 4x all squared. So that becomes a quarter sine minus 1 of 4x over 7 plus c. That's my integral. Second one, use the trapezoidal rule. So we've done that in advanced course to approximate the following, leaving your answer in exact form. And then we're going to integrate that to then find an exact answer and hence find an approximation for pi. So for the first part, set up your trapezoidal rule, use your 5 function values. So from 0 to 2, my 5 x values are 0, 0.5, 1, 1.5 and 2. Subbing those into that function, 1 over 4 plus x squared, you get f of x is a quarter, 4/17, a fifth, 4 over 25 and 1/8. So the trapezoidal rule is h over 2, the first plus the last plus 2 times all of the other values. So our h is what the x values go up by. So the x values are going up by 0.5, so that's 0.5 over 2. And then a quarter plus an eighth, that's the first f of x value plus the last, which is the eighth. And then 2 lots of all the others. So 2 lots of those 3 middle ones, the 4/17ths, 1/5, and 4/25 added together. So the area is approximately 5,323 over 13,600. So let's go and find what this is using tan. So we get 1 over 4 plus x squared. So rewriting this using our tan minus 1, we get 1 over 2 squared plus x squared. So we get a half outside of tan minus 1 of x on 2. Substitute in 2 and 0. And we get a half tan minus 1 of 1 minus tan minus 1 of 0. Now tan minus 1 of 1, that's inverse tan of 1, which is pi on 4, times by the half out the front, that is pi on 8. So that's my solution. So that's the exact value or exact area from 0 to 2 of 1 over 4 plus x squared. So if I now let part B equal to part A, so that is let the 5,323 over 13,600 equal to pi on 8 and make pi the subject, so times by 8, I get 5323 over 1700 or approximately 3.131176. Thank you.